Hi, welcome. I'm Vijay Menon. I'm from the Dart team at Google, and I'm going to be talking about Dart JavaScript interoperability. So Dart is a new programming language that we're developing at Google. It's designed for structured programming for the web, for writing large-scale web applications. And it runs on all modern browsers via compilation to JavaScript, as well as Dartium, a developer version of Chromium where we have native Dart support. I'm not going to talk a lot in this presentation about Dart itself. You can get a lot of general information at Dart at dartlang.org, so please take a look there. In this talk, I'm going to be talking about Dart and JavaScript. So as I said just before, Dart compiles to JavaScript that lets us run Dart applications on all existing browsers. But one of the questions that we've been asked from the start is, how do I mix Dart code, my new Dart code, with existing JavaScript code? How do I use existing libraries like Google Maps and so on? And I'm going to talk about how you can do that today. I'm going to give you examples of how you can call existing JavaScript, like Google Maps or so on, from your Dart application. I'm going to show you how you can invoke Dart code from JavaScript. I'll go through an example with Twitter doing that. And I'm going to show all of this running on different places. And all of this works today. So first, let me just give you a quick demo of what we can do. I mentioned Google Maps is one of the things we want to play around with. Google Maps is an API, a JavaScript API that we publish, that Google publishes, that you can use traditionally from JavaScript to write neat map applications that are tailored to your needs. And we wanted to be able to do that in Dart, and we can. So here's an example of a simple app based on one of the published examples of the Google Maps API. Everything's written in Dart. This is running in Firefox, by the way. And I can manipulate this. This happens to have the different cities that the Dart team is based in. I'm based in Seattle, but I'm in Mountain View today. So were I to go back, I can run this little app and see my path back. If I want to go see my colleagues in Denmark, well, I should probably try flying, but if I happen to already be in, say, London, I can navigate to that. So you get all of the nice responsiveness, but the code is all Dart. And again, it runs on Firefox. I can show you one other example here on my Nexus 10, where here we're running on Android, and if I open up the browser here, you can see the same application running here as well, where I can go ahead and navigate and everything just works. And again, this is a pure Dart program that's interfacing with a JavaScript API, in this case running on Android. So how does this work? Well, I will show you maps in a little bit more detail in a bit, but first I want to start with a simpler example, but also using a real API. So this is the Google Charts API, which lets me draw graphs and so on my web page. And it's a pretty big API, but we're just going to focus on some fairly simple things. So as a Dart programmer, there just happens to be a few JavaScript APIs I'd like to get access to. I'd like to be able to, first of all, put the Charts API on my web page, and then I'd like to be able to access it. And when you load up this module, it loads into the page's JavaScript context this JavaScript variable called google.visualization. And that essentially is the entry point to all of the JavaScript APIs dealing with charts. And the ones that we're interested in particular, we're going to do a bubble chart here. There's a class bubble chart we'd like to instantiate using the constructor that you can see here. And there's also a draw function where we can actually feed it data that we want. And there's also another function that lets us essentially massage data into a format that is acceptable for the Charts API. So let's quickly see what it looks like. This is actually the web page that we're going to render. It's essentially setting up all of this data from Dart and configuring it on the web page using the Charts API. So let's take a look at how that was done. Here I'm in the Dart editor, and this is the HTML file. And we're including the Google JavaScript APIs down here in this first script. That's a JavaScript script and loading the JS API. And our entire user level program is just in this Dart script, bubblechart.dart. And so there's no other JavaScript code that we had to write. We could just use the JavaScript APIs directly from our bubble chart example. So here I'm in Dart code. And the work is mainly done by this function called draw visualization. So this is essentially what gets launched when the charts API is available, and I can go ahead and populate the data. So to show how it works, what I'm going to do is actually step through this program using the editor. So I'm running here. I'm launching an instance of Dartium. And so this is actually Dart running on natively on our special version of Chromium. But JS Interop works here well too, and I get the nice features of being able to step through the browser. So here I've called draw visualization, and I've set a breakpoint over here. And the first thing I want to show attention to is, first of all, before, at the very top, in order to use JS Interop, I'm just importing this package js.dart. And I'm prefixing it with JS. So you'll see calls to js.something or other throughout this program. Those are calls to the JavaScript Interop library. So the very first thing I do in draw visualization is, remember I mentioned google.visualization is a JavaScript package that's loaded. We can get a handle to that from the Dart side by just calling js.context.google.visualization. What js.context is it's essentially a proxy, a handle to the global Dart context of our web page. And off of that context, I can now access anything, for example, Google visualization. And I'm just storing that in the local variable here called gviz. Now, if you look at the panel over here on the right, you can see that the type of gviz is proxy. Proxy is a type provided by the JS library. So we get some sort of type information, and that tells us that this is a proxy to a JavaScript object that we can interact with. So let's step through this program. So the very first thing we're going to do is we actually have data that we want to feed into the chart. And we're creating a regular Dart array here called list data. So if I just step over that, you can see over here that list data is of type array. It's a regular Dart array. Now to feed it over to the JavaScript side, I actually need to convert the Dart array to a JavaScript array. And that's very easy. I can just call this function called js.array. And if I step through this, you'll see while list data has the type array, array data, is a proxy to a JavaScript array. I'm kind of breaking this up into steps, but actually what the visualization charts library wants you to do is convert your array now to a data table that it can use with charts. And so one more step here is actually to call array to data table. That's another one of the APIs that we want to use. And again, gviz is our handle into the visualization API. So we call this JavaScript function array to data table here. We pass it in a proxy to a JavaScript array. And what we get out is a proxy to table data. And you can see the type of table data is also a proxy. And so similarly, we can create a map. So configuration options for a chart are a JavaScript map. And we can easily create a JavaScript map from a Dart map by just wrapping it in js.map here. And now we have options that is also a proxy. So I showed two ways of creating these proxies already. One, you could take an existing Dart list and convert that to a JavaScript array. You could take an existing Dart map and convert that to a JavaScript map. But sometimes you want to actually instantiate a new object. So again, going back to the chart API, we want to invoke the bubble chart constructor so we can create a bubble chart. And this syntax shows you how you can use js.proxy and create a new one, essentially, given a JavaScript constructor, bubble chart, and an element on the DOM. So we're just looking up an element. We're creating a bubble chart with that element. And what we get back, again, is another proxy to the chart in JavaScript. And now we can manipulate that pretty naturally. We can go ahead and draw the data onto the chart that we've got all set up here. So I'm just going to continue. And we can go ahead and look at Dartium, and we see the same exact thing that we saw earlier, but now this is running in Dartium. And again, here we're mixing Dart and JavaScript code in Dartium. Just below here, you can see, I'll show some more examples here, but the Google API actually provides many things beyond charts. And so you can actually see a little bit more here that we're using to actually lazily load the visualization part of the Google API from Dart and accessing, asking for the core chart packages, which actually contains bubble chart. And we're also setting up this callback here for draw visualization. So this new js.callback, and I'll go into a little bit more detail on this in a moment, is actually constructing a JavaScript callback that forwards to our Dart function here. So this is what it allows the Dart program to call back into JavaScript. Great. So that shows an example again. Here's a recap of that API. One other example, very simple example I wanted to show where we can pick up on callback is a very special use case we often get asked about is JSON-P. Now that's the ability to make a request to a server and have it send data in a format that can be launched via JavaScript. And it's something it's a convention that's used by a lot of APIs. Twitter uses it, and we want to make that work with Dart. And we can use Dart.js Interop to make that work. So let me show you our Twitter example here. And it's very, very simple. In this case, all we need to do, again, is to create a callback to a display function, but we need to give it a name in the JavaScript side. So I showed on the last example how you could read stuff off of the JavaScript context. So for example, we had js.context.google.visualization in the last example. Here, you can see that it's also writable. So what this is actually going to do is create a top-level JavaScript variable function display that's going to forward to a Dart callback. Callback here is creating a callback out of a Dart function that's usable in JavaScript. And once we have that, everything else is easy. We've set up this callback in JavaScript that forwards back to Dart. And now we can do the standard sort of JSON-P of inserting a request into our document. And in this case, we're going to Twitter. We're making a search query on Twitter about things to do with Dart. We're getting 20 items back, and we're asking Twitter to insert a callback to our display function when the data comes in. And when the display, when the data comes in, display is fired off from JavaScript, which ends up forwarding to the Dart function here. And again, we'll step through, and even though this is instantiated from the JavaScript side, we can step through the Dart code in the editor here. And so now we've made this request to Twitter. It's come back. We're in display, which is Dart code here. And data here is a proxy, as we've seen before with other things that we get from JavaScript. But we can manipulate it pretty easily. So for example, we can get the results out of it, which is another proxy object. We can get the length. In this case, it's a primitive type. So we can actually type that as an integer, and we see that we get a length of 20. We asked for 20 results. We got 20 results. And we can just iterate over this fairly naturally now. So for example, we can go ahead and get the first result. We can get the user from the first result, and that's typed as a string. So we can see the name of the current user. This is live data coming from Twitter, so I don't know what's on the page at this point. Linkify is just a Dart-specific function that is essentially just processing that text to put some nice links in there. And we can get that result, and now we can render it on our web page via Dart using some of the nice features in Dart's HTML API that essentially let us very naturally build together some HTML from that. So let's, now this would go ahead and iterate 19 more times, but let's just go ahead and jump ahead and see what it looks like. So here it is. We've got the 20 different Twitter results, and we've got what people have been talking about recently on Twitter about Dart. And when I ran it this morning, one of the first things I saw was a reference to our Dart cookbook, which kind of a cool link. You can check out and see stuff there. But it's interesting to see what people are doing. So let's go back to let's go back to our slides here. So what we saw here were proxies going back and forth between Dart and JavaScript. And these aren't all the proxies, but here are a couple examples just showing what's going on from our visualization example, from our charts example. We actually had a chart object on the JavaScript side, but we were able to create a proxy on the Dart side to interact with it. Going the other way, we had this draw visualization callback, as well as the other display callback in our Twitter one, which looks exactly the same as here. And we were able to materialize that as a proxy on the JavaScript side. So JavaScript can call into Dart. Dart objects can reach into JavaScript going the other way around. So recapping, to create a Dart proxy to JavaScript, we saw 3 different ways of doing that. First, you can invoke a JavaScript constructor and create a proxy by creating a new object. You can create a new array, given a Dart array. You can create a new map, given a Dart map. And you can also create callbacks in JavaScript back to Dart. And you've noticed the two syntaxes, callback.once and callback.many, and I'm going to talk about that in a bit, but they both essentially expose a Dart function to the JavaScript side. All right, let's get back into a somewhat more interactive example, the maps example. And the maps example is interesting because it's more of an interactive application. I'm running things many, many times. So it actually highlights some stuff about proxies that you need to know about if you're really pushing the boundaries of what JS Interop can do. So one of the things you have to worry about JS Interop is memory management, because we're essentially dealing with two different heaps. And although these look like pointers from Dart objects to JavaScript objects and vice versa, that's kind of an abstraction that we give the programmer to make it easier to write programs. What this really kind of looks like under the hood is you really have two disjoint heaps. You have a heap of JavaScript objects over here on the right, and you have a heap of Dart objects over here on the left. And we're doing the magic under the hood to make it look like you've got references from one to the other by essentially keeping these IDs around and ensuring that you get a consistent mapping between the two. One of the tricky issues here is memory management. I can show that very clearly if you look at this example here. Draw visualization, for example, is a callback, is a function on the Dart side. Now, normally, the Dart VM will garbage collect that out once we're no longer using it. But in our system, this ID2 is going to keep that callback alive forever unless we explicitly get rid of it. Or implicitly, I should say, sorry, unless we implicitly get rid of it in some fashion. We have to do something at either the JS Interop layer or the developer layer. So the Dart garbage collector only sees Dart objects is essentially what the problem is here. And the JavaScript garbage collector only sees JavaScript. So we need to do something to help these things manage memory. So to show exactly the issues here, let me go back to our maps example. So maps is a somewhat more interesting example in that it's again more interactive. As I showed you, you can do many things with it. You can kind of interact and do multiple steps with it. It's not just one, setting something up and displaying it. So let's just walk through this code really quickly, and then we can see it running. So first of all, main is the entry point here. And you'll notice, like before, I have, instead of Google.visualization, I have Google.maps. And js.context.google.maps is giving me the proxy to the maps object. But I want to use this maps object across multiple events. So what I have to do is retain it. Okay. Now, if I don't retain this, I'm essentially going to go ahead and collect it, or the JS Interop layer is going to go ahead and collect it at the end. It's going to deallocate all those handles so it can clear memory. So if I don't retain it, I'll be able to use it in this method, but in some callback that happens at some later point, it will be an invalid proxy. So retain keeps it around, and you'll kind of notice this pattern here of I have these global variables, maps, directions display, direction service. I want to use retain to make sure that those global variables are valid beyond a single event. So you can see here that, again, I'm creating a map. I don't need to, of options. So to create the options, I populate it with this map. I can use, again, maps here is referring to the API. I can use a roadmap to indicate what kind of map. I can create a latitude, longitude object, feed this all in. I don't have to use retain here because these are all just used in the process of constructing one Google map. This is the call to construct a map on a certain canvas element. And then display is the component that actually displays the results. And that's updated interactively. So I need to go ahead and retain that. Now it's one of my other global variables. I'm using this across events, so I need to retain it. And then finally, direction service is actually the bridge in the Maps JavaScript API that goes and talks to Google servers and actually gets the directions information. So again, we're going through the JavaScript APIs. So we need to initialize the service, and we need to retain it so we can use it for new queries. All right. So we're essentially setting up our handlers here. So when I go from Seattle to Mountain View or Portland or whatever, it initiates a new request. So it's going to calculate a route, It's going to figure out the start and end based on the options I've given it, and it's going to route a request. And again, the request here is initiating a callback. So I'm calling into JavaScript and saying, when this request is done, call back this Dart function. And I use js.callback.menu to set it up. And it's an anonymous closure in here, so I don't actually have to allocate a function. I can do this nicely in line, which essentially says in Dart code, OK, when the request comes back, well, either it's OK, and I'm going to go ahead and display the directions, or I wasn't able to compute. These are different continents, and it's going to suggest that you fly instead. So let's go ahead and run this from Dartium. It's the same app I showed you before on both the Android device and Firefox. And here I'm starting in Seattle. I go down to Portland. So notice that these are different events, right? So every time I'm doing this, I'm actually clearing out proxies and then allocating new ones to make a new call. Now in this case, you'll notice everything's working as usual, but I have this print message here, and it's calling this function called proxy count. And that's more of a debugging tool for you to tell if you're using this app in kind of a more of an interactive way. If you're using this library in a more interactive way, it tells you essentially how much is live and whether you're leaking proxies. And you can see here that the first time I called it, it was 6. The next time I called it, it was 7. Let's go ahead and do this a few more times. We'll go from Denmark to Germany to St. Petersburg. Now, every time I call this, I see that the number of live proxies is increasing. So that should be a warning sign. And in fact, I talked about callback.once and callback.many. That's kind of a tool here that you can use to manage the proxies. Now, it turns out the difference between this is that callback.once is essentially telling the system, I have a callback, it's only allocated, it's only invoked once. Callbacks by definition have to live across events, so we don't clean them up automatically. But if you do callback.once, it will fire once and it will clean itself up. If you do callback.many, it will create that callback and it will persist. So it's essentially a callback that you might call many, many times. In this particular case, every time I make a new request, every time I have a different pair of cities, I'm making a new request with a new callback. So I'm creating a callback every time. And because I'm using callback.many, I have an extra proxy running every time. But in this case, this callback only gets invoked once. So I can go ahead and make this once. So even though the number of live proxies is increasing very slowly, so unless you're running this app for a long, long time, you wouldn't necessarily notice this. We build large-scale apps that will, we want to be able to run these apps for weeks and weeks without causing issues in the browser. And so if you're writing that kind of app, you really do want to make sure you don't have these kind of leaks. And again, here by using once, we can get kind of the effect we want, even in this very interactive application, and clean up after ourselves. And in this case, we have a nice small constant number of proxies. And that's what we want to see. We want to see as we use this app, the number of proxies is some small constant, and in this case 6, and therefore we know that we're not leaking. Great. So again, the takeaway from this is you do need to think a little bit about managing memory carefully if you have an interactive application. You can keep a proxy alive with js.retain. You can release it when you're done with js.release, although a common pattern is you have globals or such. We have single versus multiple execution callback, so js callback.once, and this should be js.callback.many for multiple execution. And you can track the total number of proxies for debugging by using proxy count. So thanks. You can learn more about this, learn more about Dart in general by going to dartlang.org. And one of the new things that we've put up there on dartlang.org is a cookbook that will give you a lot of quick start recipes on how to use Dart, including JavaScript Interop. We'll have some information there. If you want to learn more about the JavaScript Interop library and how to get started with it and add it to your application, go to our GitHub page that has the JavaScript package. It will show you how to get started with a simple Hello app, and it'll show you docs on all the APIs we provided, as well as samples, all of the samples that we've shown today, and source code. It's a collaborative project, and we get updates from people both inside and outside of Google who've made lots of big contributions to it. Thank you.